Welcome to Ask and Learn.
This question covers nomenclature for complex ions. And to start off with, we've got this cobalt complexing with 3 ammonia and 3 cyanide molecules. Okay, to start this off, we're going to, take inventory of what we have. The first thing we have to do is write out the formula. So the first thing we should do is write out our big brackets. When we're writing a complex ion, then with a metal center, then we start off with square brackets and the metal center. So in this case, it is going to be cobalt. Next thing we have to do is we have our NH3. So we're going to go ahead and write that. So NH3, we've got that 3 times. And we have got our cyanide molecule. So we're going to go ahead and write that. Cn 3 times as well, and close it off within our brackets. The next thing we should do is take inventory of the oxidation number and whether or not we have L or X type ligands in order to help us determine what sort of charge this ion will have. And we've got 3 amino groups and 3 cyanide groups. The cyanide groups are X-type ligands and the amino groups are L-type ligands. And our oxidation state, remember, is 3+ on our cobalt. So what that should tell us is if we had CO and NH 3,6, then this would produce a 3+ complex. And every time that we reduce this down to reduce this and add an X-type ligand, we would reduce our charge from 3+ to 2+ to 1+. And then when we have 3 L-type and 3 X-type, then our charge is actually overall going to be 0. And when this happens, when we don't need these brackets anymore, because this is no longer an ion, it's a neutral species. So we can go ahead and write out the name of this. And this goes alphabetically by order of the substituent group. So in this case, we would have triamine, tricyano, cobalt 3. And that would be the name of this complex ion or compound. This would be the name of this coordination compound. In our next example, I'm just going to take a little bit of time at the beginning to kind of draw out what we'd expect to see, because we are using a chromium 3+ center and we are using ethylene diamine ligands. And these ligands are special and they are different from the ones in our first example. In our first example, we were using monodentate ligands. And in this example, we are using bidentate chelating ligands. So what this means, what a chelating ligand is just a ligand that attaches in more than one place. We see that we're given that we have a coordination number of 6. So we know that this chromium should have octahedral geometry. So we can go ahead and draw that. Chromium should have 1, 2. Should have some sort of geometry like this, octahedral. And we're going to go ahead and draw in our N, our nitrogen, connected to each, and there should be a connection between 2 of them like this. And so as you can see, that ends up with 3 nitrogens, and they have 2 centers. They connect at 2 ends, and as a result, we are going to have to use special prefixes to write this. But first, we can go ahead and write out what this compound would be. So we're going to do that in red. Start with our brackets, start with our metal center, Cr, and then now we have our N2 try this night, right? It's C2H4 in H2. And we're going to go ahead and throw it back in here, 3. And these ligands are L-type. They're neutral ligands. And so we have a 3+ center here and 6 ligands. Or, sorry, 6 connections, 3 ligands. So we would expect this to be a 3+ compound. And as a result, we would go ahead and call this tris, because it's a chelating ligand, tris ethylene diamine cobalt. 1, 2, 3. And that's how we would solve this problem.